Good morning. I'm Meena Tekriwal, Assistant Professor from Punima College of Engineering, Engineering Chemistry 1FY203. Today I'm presenting topic cracking. What is cracking? Cracking is the process of breakdown of high molecular weight of hydrocarbon having high boiling point into simple or lower molecular weight of hydrocarbon of the low boiling point. Example, decane here when subjected to cracking it converted or cracked down into N-pentane and pentene. Decane having the boiling point 174 degrees centigrade, whereas the pentane and pentene having only 36 degrees centigrade. Importance or significance of this process cracking. The fractions obtained by fractionation of petroleum, that is gasoline, has the highest demand as a motor fuel, but the yield of this fraction is only 20% of the crude oil or petroleum, the gasoline known as a straight run gasoline. Hence it is only after suitable blending. Moreover, there is a surplus of heavier petroleum fractions. To overcome this difficulty, the middle or heavy fractions of the fraction distillation of the petroleum are cracked to get more valuable low boiling point fraction or hydrocarbons such as petrol or gasoline. This petrol which we made up by the cracking is of better quality than the straight run petrol. Types of cracking. Cracking are of two types, thermal cracking and catalytic cracking. Thermal cracking, where the cracking occur by the heat, whereas the thermal cracking, catalytic cracking known as, which take place in the presence of catalyst at comparatively lower temperature. Thermal cracking, which take place by the heat, may be are of two types, vapor phase and liquid phase thermal cracking, on the basis of how the heavy oil crack down. If the heavy oil vapor phase crackdown known as vapor phase thermal cracking, if the heavy oil liquid phase crackdown known as liquid phase thermal cracking. Catalytic cracking again can categorize into category on the basis of how the catalyst used. If the catalyst used as a fixed position known as fixed bed, if the catalyst used as a moving position known as moving bed or fluidized bed, catalytic cracking. First we will talk about thermal cracking. Thermal cracking. Cracking of heavy oil hydrocarbon into smaller hydrocarbon of the range of petrol take place by two types. As we know, vapor phase and liquid phase. So vapor phase thermal cracking take place at temperature 600 to 650 degrees centigrade, whereas liquid phase thermal cracking 475 to 530 degrees centigrade. Pressure for vapor phase, it is comparatively low, 10 to 20 kg per centimeter square, whereas for liquid phase it is 10 times greater, 100 kg per centimeter square. Vapor phase, the petrol obtained is of better quality, greater than 70 octane number, whereas for by the liquid phase it is okay, that is 65 to 70 octane number. Vapor phase thermal cracking required less time than the liquid phase thermal cracking. Now, catalytic cracking. Now, catalytic cracking is the process in which heavy oil is heated in the presence of catalyst. As we know, catalyst increase the rate of reaction. So, this catalytic cracking is comparatively better than the thermal cracking. Generally used catalysts are crystalline substances. Catalyst cracking require much lower temperature and pressure as compared to thermal cracking. Catalysts generally which used here are bauxite, zeolite, crystalline hydrated aluminum, silicate, etc. Catalytic cracking, as we know, are of two types, fixed bed and moving bed. So first we will talk about fixed bed catalytic cracking. This is the technical diagram of the process of fixed bed catalytic cracking. So first we discuss about the process. Heavy oil, which here uses as a raw material. So this heavy oil, which is the heavier fraction of the petroleum, take here and subject it for the preheating inside the preheater. Inside the preheater, it is preheated at 425 to 450 degrees centigrade, and then the vapor of the heavy oil sent inside this chamber known as a catalyst chamber. Here the catalyst fixed by the help of clay here. So this chamber where the catalyst is fixed known as fixed bed catalytic chamber. So the process known as a fixed bed catalytic cracking. So in this chamber the cracking takes place, and then the cracked vapor sent inside this chamber known as a fractionating column. Fractionating column actually fractionated all the cracked vapors here or hydrocarbon on the basis of their boiling point. So the lower boiling point fractions recover here and the high boiling point fractions remove as a heavy oil. So lower fractions cool down by using the condenser and converted into liquid, but some of the gases may be dissolved here. So to remove gases, stabilizer uses. Stabilizers remove the gases and recover the gasoline or petrol. Some of the important points of the fixed bed catalytic cracking. This reaction chamber which uses for the fixed bed catalytic cracking, it is 425 to 450 degrees centigrade under pressure 1.5 kg per centimeter square. During the cracking, this is most important that during the cracking free carbon is also formed which deposited over the catalyst. Then the flow of vapors of heavy oil is passed over the second set of reaction chamber and catalyst in earlier chamber is regenerated. It is regenerated by the burning of carbon deposited over the catalyst with the help of air and removed as a form of carbon. Now the next is moving bed catalytic cracking. Now what is the moving bed catalytic cracking? This is the technical diagram of the process of moving bed or fluidized bed catalytic cracking. Here the raw material is heavy oil taken and subjected to preheater. For the preheating, it is preheated at the same temperature 425 to 450 degrees centigrade, and then the vapor of the heavy oil mixes with the catalyst powder. So here the catalyst actually move with the heavy oil known as moving bed or fluidized bed catalytic cracking. Catalyst powder mixes with the heavy oil vapor and sand inside this chamber known as a reactor. This reactor actually where the reaction or cracking take place. It is on 500 degrees centigrade. Here the cracking take place and the heavy oil vapor crack down. That cracked vapors only allow by this separator known as cyclone centrifugal separator to go outside. All the solid particles such as catalyst remain here. That catalyst due to the deposition of carbon actually become exhaust or spent. So this spent catalyst by the help of this air blower sent inside the another chamber. This chamber known as regenerator. In this regenerator at 600 degrees centigrade in the presence of air, spent catalyst burn off and this carbon as a form of carbon dioxide expelled out by this help of cyclone centrifugal separator, and the catalyst which is regenerated by the help of this hopper again mixed with the heavy oil vapor to cracking process. Now the cracked vapor which removed by this reactor sand inside this fractional distillation column for the fractional distillation. The lighter fractions recover and cool down, and then the gasoline which is recovered, some of the dissolved gases may be present here. So to remove dissolved gases, it sand inside the stabilizer. Stabilizer remove the gases and stabilizes the gasoline. So the main important points of this moving bed catalytic cracking. The most important point, the cracked vapor after separation of dust separated go to the fractionator where gas oil is separated from vapor of the gas and gasoline. This gas and gasoline vapors are condensed in the condenser and are separated by a stabilizer at last. Here the significance of this process, here simultaneously the cracking and regeneration of the catalyst take place. So it is comparatively better than the fixed bed catalytic cracking. Thank you.